Today we're going to actually start our unit of proving triangles congruent. For the next couple of lessons, we're going to be discussing 5 theorems. They are SSS, SAS, ASA, AAS, and HL. And we're only going to do 2 at a time for now because it is a lot of information. But basically, what we had learned before is in order for you to know that 2 triangles are the exact same size, I needed to draw 3 pairs of tick marks, and I needed to draw 3 sets of angle markings. So I would need to draw this picture for you. That means that every side and every angle has a congruent match. So the triangles are exact replicas of each other. What these theorems that we're going to talk about say are that you don't necessarily need me to give you all that information. I can just give you a few pieces of information, and that's enough knowledge to go ahead and assume the triangles are congruent. That's like your okay to say they're congruent mark. So the first theorem is the side-side-side theorem or postulate. And what it says is 2 triangles have 3 pairs of congruent sides and the triangles are congruent. So if I look over here to the right, you can see there are 2 triangles. Every single side has a corresponding tick mark. In other words, every side has a mate. If that happens, you can see we have one side marking, another side marking, and a third side marking. I can see I have SSS theorem going on right here. I have that theorem, I have that information, so I can go ahead and say, all right, well then, since all those sides are the same, all these angles are the same as well. Those triangles are replicas of each other. They are the same. So it's going to be a little different than what we did before this, because before I gave you all the markings, and today I'm going to show you which markings you really only need in order to know that they're all the same. The second theorem we're going to talk about is the side angle side theorem, which we abbreviate as SAS. Now this is going to be a little more confusing, so bear with me here. But it says if 2 triangles have 2 pairs of congruent sides and a congruent included angle. Included means in between. Then the triangles are congruent. All right, let me start by defining included. That's probably new to you. If you look over here, let's look at triangle BCA. You can see a side marking and another side marking. And where those two sides come together, which is right here, there is an angle marking. So this angle is included between these sides. This angle is the middle of these two sides. If I moved this rainbow marking over here, then my angle would actually be outside. It would no longer be in between, and it would actually read as SSA, which is not a theorem. So we have to be really careful. That little rainbow marking has to be precisely in the middle of the sides. And we can see the same thing here. I have a side marking, another side marking, and I have an angle marking. So we can see that I have enough information to use SAS. And I can go ahead and say, all right, those triangles are congruent. So therefore, I can put tick marks on the remaining side. I can put rainbow markings in the other angles. And I can safely say that those triangles are replicas of each other. So in the bottom, it says to name the postulate. So that means either SSS or SAS, which theorem can be applied, or state if a theorem can't be applied. Maybe I didn't give you enough information. So let's find out. When I look at example 1, I see a side mark, and a match for each of them. We don't have another side marking, so I definitely can't use SSS here. I don't have the set of 3 tick marks I need. And I didn't draw any rainbows. If I would have drawn rainbows right here and here for you, you maybe could have used SAS, but you don't have any markings. There's nothing you can put in yourself. So these are not congruent due to lack of information. What's going to be super important is that you don't add in any markings that are unjustified. So you can't just put tick marks right here and say, well, H is the middle. How do you know H is the middle? I never said H is the middle, and I didn't tell you those two sides were the same, so you can't do that. So that's just something to be aware of. There's only 2 cases where you can make your own markings, and we're going to talk about both of them in a minute. If I look at example 2, I see a side mark, an angle in between, and the other side mark. And I also have that same thing going on right here. So I have really enough information to use SAS. So we're going to write yes by the SAS theorem. Number 3 should look familiar. You can see you have all 3 sides that are marked. So the answer is yes by SSS. All right, example 4. Before you make a decision, I see one marking that you can make on your own, and that's right here. Anytime you have crisscrossing lines, you've got to put in your own rainbows because I will not be doing that for you. All right, so in other words, the rainbows that are there are invisible, so you have to draw them. So just kind of get in the habit that anytime you see those crisscrossing lines, you put those little rainbows in. Now this one we got to be careful. I see a side marking, an angle marking, and a side. So it would appear SAS, but on this side I have a side, and an angle. So I have over here SSA, and over here I have SAS. So these do not match each other, so they are not congruent. we're actually going to do a full-fledged proof in number 5. So if you remember, to do a proof, you need a statement and a reason column. And what always, always, always comes first is your given information. You have to restate it. So you're going to write M is the midpoint of XY, and AX equals AY. And the reason for that is it's given. Now, as we do a proof, we're also going to make markings in our picture for every statement we make. So we were given that AX and AY are the same. I can put tick marks on them. I'm going to use the fact that M is the midpoint. If that's true, then these two sides would have to be the same because M is in the middle. So we actually need to take the time and state that. We need to say that XM equals MY. And the reason that we know that is by definition of midpoint. All right, that should be somewhat familiar from way back in chapter 2 when we were dealing with midpoints. You actually have to go the extra step and tell me which sides are the same because of that midpoint. So I'm looking at my triangles. I see a side marking and another side. For each triangle, I either need to get a rainbow somehow or I need to get a third side marking. And you can't just put in whatever you feel like. There has to be a valid reason for what you're doing. So if I look at side AM, I'm actually going to put tick marks on it because that side is shared. It's going to obviously be equal to itself. So we're going to write AM equals AM. And we call that the reflexive property. Do you remember that? Reflexive means something equals itself. Now I'm looking at my triangles, and that's awesome. I now have 3 side markings, so I can now use SSS. So we are going to write that triangle AMX is congruent to triangle AMY because of the SSS theorem. And that's it. You're done. Keep in mind that the ordering of your letters has to match up. So AMX matches up with AMY. You can't switch this around. Plus, you can also see it up here. This is what you were asked to prove. So that should always be your last step. So why switch the order of the letters around if I gave you the correct order in the first place? All right, number 6 is a little different. You don't have to write a proof. You simply just have to tell me, can you prove the triangles are congruent? Do we have enough info to use SSS or SAS? So let's put in these markings first off. RSG and RSH are both congruent, so they can get a rainbow. SG and SH are also congruent. And right away, I recognize that RS is a shared side, so I must put tick marks on that. Remember, Mrs. Stotts will not be putting them on for you. You've got to do that yourself. So let's see, I have a side, I have an angle in between, and the other side. So, yes, because of the SAS theorem. I can use the theorem. I have enough information to do that. So the triangles are congruent. We can cross out number 7. So I'm going to save that for another time. All right. Number 8 is another proof, but I think it's more your guys' speed because it's a fill-in-the-blank proof. So, as always, your given needs restated. So you're going to write given. This was also given, so I need to write given in step 2 as well. Okay, if you just write it all as one statement and just have your first step given, or you can break it into parts, it's up to you, it does not matter. What I want to do is put my markings in. Since I was told that information, I want to mark it in my picture. So HF and HJ are the same, and FG and JK are the same. So number 3 is saying, since H is the midpoint, I can put marks on GH and HK. And the reason I can do that is, once again, because of the definition of midpoint. I now have enough info to use side, side, side. So let's finish it up. Triangle FGH is congruent to triangle JKH. That's what I was asked to prove. And that is the SSS theorem. All right, number 2 is giving us some information, and they're asking what else would the problem need to tell you so that we can use the SAS theorem. Start by putting tick marks on these two sides because they're both 7, so that means they're the same. And I want to put tick marks on AC since it is a shared side. We're going to number these angles just to make our life a little easier. So if we look at these two triangles, I can see my two side markings in each triangle. I need to figure out what are the in-between angles. And if you can't see them, they're actually going to be 3 and 5. So I would need to tell you that angle 3 and 5 are the same in order for you to be able to use the SAS theorem. And number 3, do we have enough info to say those triangles are the same? Right away, we're going to put in our rainbows at the crisscrossing angles. Right, vertical angles are always congruent, so we need to mark that. This is kind of like our earlier example. I see S, A, S. So I can see that angle is right in between those two sides. Whereas this triangle doesn't have an angle between the S's, so it's like an SSA. So the answer is no, because one triangle is SSA, the other is SAS. So again, those were 2 theorems of 5 total. And those 5 again were SAS, SSS, AAS, ASA, and HL. So we're going to learn how to use all 5 theorems. So next time we'll be talking about AAS and ASA. Just as a heads up. Microsoft Word documentation.